Hi, welcome to my channel pibyme Maths. This is WST02. In this video, we are going to solve May-June 2021 Statistics 2 paper. Let's look at question number 1. Spanish sells seeds and claims that 5% of its pansy seeds do not germinate. So that's the percentage of seeds that do not germinate. So it can be a probability of success or failure depending on the question. So we need to read the complete question. A packet of pansy seeds contain 20 seeds, N is 20. Each seed germinates independently of the other seeds. Okay, find the probability that in a packet of pansy seeds, more than 2, fewer than 5 do not germinate. They are talking about, do not germinate. So you can take it as probability of success. So X follows binomial distribution of 20, 0.05. So for I, they want us to find more than 2, fewer than 5, which is X is less than or equal to 4 minus P of X is less than or equal to 2. Let's get the table values. For N is 20, probability is 0.05, X is 4 and 2. N is 20, the first column is the probability of 0.05, 4 is 9974, 2 is 9245. So 0.9974 minus 0.9245. So when you subtract, you're going to get 0.0. 14 minus 5, 9, 6 minus 4, 2, 9. That's all. Now in double I, it says more than 18 seeds germinate, do not germinate. So if more than, out of 20, more than 18 of them germinate, for example, let's say it's 19. So there is only one seed that do not germinate. So we need to find P of X is less than or equal to 1. You can do one more thing. You can take the probability of success as 0.95 because 5 of them do not germinate. So 0.95 is the probability that the seeds do germinate on 20. And you can find P of Y. This is Y follows more than 18. You can calculate this also. But since we already defined the variable and distribution X, we can take it as more than 18 germinate is same as less than or equal to 1 do not germinate. Just take the table value. The table value is going to be 7358. 0.7358. That's all. Part B. Jem buys 5 packets of pansy seeds. Calculate the probability that all of these packets, that means 5 out of 5. Okay, so N is 5. What is the probability of success here? Probability of success is more than 18 seeds that germinate, which is what we calculated in the previous part, 0.7358. So here you can write Y follows binomial distribution of 5, 0.7358. They want us to find P of Y is equal to all 5 packets. So it's 5C5, probability of success P to the power 5, probability of failure which is 1 minus P to the power 5 minus 5. 5C5 is 1, this power 0 is also 1. So you can just put 7358 to the power 5. That's the answer. 21567, 0.21567 ... and I'm gonna round it to 3 significant figure. That's all. Now let me explain one more thing here. What if the same question says calculate the probability that all of these packets contain more than 18 seeds that do not germinate? So we know this probability is the probability for more than 18 seeds that do germinate. So you need to subtract this from 1. Take this as a probability of success. So it's going to be 0.2642. This is P. This value is Q. Okay, that's why you need to read the question carefully. In this case, that's just straightforward. Part C. Jem believes that Spancy's claim is incorrect. She believes that the percentage of pansy seeds that do not germinate is more than 5. Write down the hypothesis. So null hypothesis is it is equal to 5. Alternative hypothesis, Jem believes it's more than 5%. That's all. Part D now. Jem planted 100 seeds. So N is equal to 100. 100 seeds she bought from Spani and found that 8 did not germinate. 8 is the observed value. Okay. Use a suitable approximation to carry out the test at 5% significant level. Okay, they are talking about do not germinate. We know the probability that do not germinate is 0.05. So here we are talking about binomial distribution of 100, 0.05. We need to basically write, assume that H0 is true. So we can write, use another variable 100, 0.05. Now since it's a one-tailed test, you need to calculate W is greater than or equal to observed value, which is 1 minus less than 8 or less than or equal to 7. 100 is not in the table. So is it there? We have 50. Yep, 100 is not there. So I'm going to use a calculator now. Go to distribution, binomial CD, number 2. The value of X is 7. The value of N is 100. Wait, but we did not read the question carefully. The question clearly says use a suitable approximation, right? So when N is large and P is small, we don't just blindly apply the distribution. We need to apply approximation. So N is large, P is small. It can be approximated by Pearson, right? Lambda is NP is 100 times 0.05 is 5. So we can write J follows Pearson distribution of 5. So we need to write that first. We need to write these steps first. And then we need to find P of J is greater than or equal to 8, which is 1 minus J is less than 8 or less than or equal to 7. So the lambda value is 5, X value is 7. Let's use the table. The lambda is 5, the last column, X is 7 is in here, 8,666. So 1 minus 0.8666 is 0.1334, which is bigger than the significant level. The significant level is 5%, right? So remember this, when the calculated value is smaller than the significant level or the observed value lies in the critical region, you reject H. Not always remember this condition. Here the calculated value is bigger than the significant level. So you need to write do not reject H naught first. So we are going to accept this. We don't accept H1. So there is no reason to believe, or you need to write there is insufficient evidence to suggest what Jem believes, or insufficient evidence to suggest that the percentage of pansy seeds do not germinate is more than 5. You need to write the conclusion. Question number 2. Louis makes and sells rugs. Okay. He knows that falls occur randomly in his rugs at a rate of 3 per every 4 meter square rug. Find the probability that there being exactly 5 falls in one of his rugs that is 4 meter square. They are using the same measurement, so you can take lambda as 3. X follows Pearson distribution of 3. They want us to find P of X is equal to 5, which is e to the power minus lambda to the power 5 over 5 factorial. So it's going to be e to the power minus lambda times lambda to the power 5 over 5 factorial. 0.1008 so I can round it to 3 significant figure. Let's move on to part B now. Find the probability that there are more than 5 falls in one of his racks, that is 6 meter square. We know 3 falls in 4 meter square rack, so for 6 meter square, that's going to be 18 over 4, 9 over 2 is 4.5. That's the new lambda. So you can write y follows Poisson distribution of 4.5, and they want us to find more than 5, which is 1 minus equal to 1 minus less than or equal to 5. Let's get the table value for lambda is equal to 4.5, x is 5. Lambda is 4.5, x is 5. 1, 2, 3, 4, 5. 7029. 1 minus 0.7029, 0.2971. That's all. Part C now. Louis makes a rack that is 4 meter square in size and finds it has exactly 5 falls in it. Okay, it's 4 meter square and there is exactly 5 falls in it. Write down the probability that the next rack Louis makes, which is 4 meter square, same in size and same number of falls. Give your reason. Okay, in part A, this is what we calculated, right? For 4 meter square rack, exactly 5 falls, we got this probability. And when she makes another rack, here we are applying Poisson distribution, so we are gonna assume that the falls are occurring independently. So just because she made one 4 meter square rack and got 5 falls in it, when she makes the next rack with the 4 meter square size and she finds exactly 5 falls, the probability should be the same. It will not change. Therefore, probability is equal to 0.1008. What is the reason? The falls occur independently. You need to write the reason. So it's the same probability that we found in part A. Part D now. A small rug has dimensions 80 centimeter and 150 centimeter. Okay, when you multiply it, 80 times 150 is 12,000 centimeter square. So you can write 80 times 150 divided by 100 centimeters in a meter. So we need in meter, right? Because everything is given in meter. So let's calculate this. 12,000 divided by 100 times 100. You're gonna get 1.2 meter square. That's the size of the rack. Falls still occur randomly at a rate of 3 per every 4 meter square. Okay. Louis makes a profit of 80 pound on small rack. This is a small rack. Okay. That he sells contain no falls. Okay. First of all, the lambda is, we know, 3 per 4 meter square. So for 1.2 meter square, it's gonna be times 3 divided by 4. That's 0.9. So F follows Poisson distribution of 0.9 here. Okay, that's a distribution. Now read the question further. He makes a profit of 80 when there is no fault. Okay, that means if P of F is 0, no fault, he makes a profit of 80. Okay, and he makes a profit of 60 if there is a fault. So if the fault is, instead of 0, if it is greater than or equal to 1, he sells it for, he makes a profit of 60. Okay. Now he sells n small drugs. So you need to multiply everything by n. That will give you the expected profit. But it's given already, he expects to make a profit of at least 4,000. So it should be greater than or equal to 4,000. Hope you understand this. So f is 0. Using this, f is 0 is e power minus lambda. Lambda power 0 is 1 divided by 0 factorial is also 1. So just leave it times 80 plus. You can write f is greater than or equal to 1 is 1 minus p of f is less than 1 or p of f is 0, right? So you can simply write 1 minus e power minus 0.9 because that's a property for f is 0, right? Times 60 n is greater than or equal to 4000. Find the minimum value of n. So just calculate these values, divide by 4000, that's all. So when you open the bracket, you'll get 80 minus 60 is 20 e to the power minus 0.9 plus 60 times n is greater than or equal to 4000. So n is 4000 divided by 20 e to the power minus 0.9 plus 60. 58 point n is greater than or equal to 58.71, therefore n is equal to 59 is the answer. That's all. Part E now. Louis wishes to increase the productivity of his business and employs Rhiannon. Falls also occur randomly in Rhiannon's rugs and independently to falls made by Louis. Okay. Louis randomly selects 10 small rug. What is a small rug? A rug with this dimension, right? So for that we know lambda is 0.9, right? So they are making 10 small rugs. So lambda is 10 times 0.9. It's gonna be 9. Okay. 10 small rugs made by, selects 10 small rugs made by Rhiannon and finds 13 faults. 13 is the observed value now. Test at 5% significant level whether or not there is enough evidence to support the suggestion that rate at which faults occur is highly for Rhiannon than for Louis. Okay, for Louis it's 9, right? For 10 times this is 9, the faults is 9. Now Rhiannon's faults must be higher than this. So state your hypothesis clearly. H0 is lambda is equal to 9. H1 is lambda is greater than 9. So we need to assume that H0 is true. That means the variable follows Poisson distribution of 9. Now we need to use the observed value 13 and apply the upper tail test. So it's P of j is greater than or equal to 13, which is 1 minus P of j is less than 13 or less than or equal to 12. Let's get this value. Lambda is equal to 9, x is 12. Lambda is 9, x is 12. That's 8758. 1 minus 0.8758, which is 0.1242, is bigger than the significant level. So if the calculated value is bigger than the significant level, do not reject H0. What does that mean? We accept H0, we reject this. So when you write the conclusion, you need to write there is insufficient evidence. There is insufficient evidence to support the faults occur higher for Rhiannon than Louis. So you need to write that conclusion, otherwise you will lose a mark. Okay, because insufficient evidence to write support H1. What is H1? The faults occur higher for Rhiannon than for Louis. That's all. Let's look at question number 3. Sketch f of x. Okay, it's a 2-mark question. This is a straight line. This is a cubic function. So when they ask you to sketch f of x, first of all sub in these values. f of 1 is 0, y minus 1. F of 2 is 6 over 25. Not only that, you need to sub in 2 here also. F of 2 is, I don't need to show any working, 3 over 50 times 2 square is 4 times 4, 16 minus 2 cube. That's 12 over 25. These two values are not same actually. What does that tells us? There will be a gap between the two graphs. They are not connected. If when you sub in 2, you get 6 over 25. When you sub in this 2, you get 6 over 25. That means both the graphs are connected. In this case, two different values, they are not connected. And then f of 4. 4 is going to be 4 cube minus 4 cube. It's going to be 0. Okay. So let's draw f of y. X-axis. Always label the axis first. Y, f of y, origin. Now from 1 to 2, it's a straight line with the positive slope. Starting from 0 goes to this point. So from 1 to 2, we have to have a straight line. This point is 6 over 25. Okay. And then, what graph is this? It's a cubic graph, right? Coefficient of x cube, y cube is negative, so this is going to be the cubic graph. When you equate it to 0, 4y square minus y cube is 0. You don't need to show this working, okay? Y square times 4 minus y is 0. Y is 0, 0, 4. Two repeated rows. We have learned this in pure math 1, right? Sketching a cubic graph. We need to sketch this graph. That means the graph is gonna look like this. But we sketch the graph only from 2 to 4. Not this part. We don't need this part. So okay. When it's 2, it's 12 over 25. Let's say 12 over 25 is here. Definitely bigger than 6 over 25, right? From 12 over 25, you have to have this space. You see there is a gap here because these two values are not same. These two values are not same. That's why there is a gap there. You don't need to show these workings. That's all. It's just a 2-mark question. Part B, find the mode of y. The mode of y is the y value at which the maximum occurs. This value at which this maximum occurs. Do not assume that okay, it's a midpoint of 2 and 4 and write it as 3. That's wrong. You need to use calculus, differentiation, differentiate this function. That's a function, this, right? Representing this figure. Differentiate it, equate it to 0. That's how you find the mode. So you need to write d by dy of 3 over 50 times 4y square minus y cube is equal to 0. So 3 over 50, 4y square becomes 8y. Y cube becomes 3y square is 0. Bring the number to the other side. You will get 8 minus 3. Y is 0. So y is 0, 1 at the origin, and y is equal to 8 over 3. Therefore, mode is y is equal to 8 over 3. That's a mode. Part C, find E of y square. Let's calculate E of y square now. To find E of y square, we have to integrate the function and y square f of y dy. That's a rule, right? So integral y square, the first function is a linear one, 6 over 25 y minus 1, 1 to 2. 6 over 25 y minus 1 dy, the limit is 1 to 2, plus integral y square, the second function, 3 over 50 times this, 2 to 4. 3 over 50 times 4y square minus y cube dy. We need to integrate and sub in the limits. Keep 6 over 25 outside. You will get, open the bracket, y cube minus y square dy plus 3 over 50 integral 2 to 4. 4y power 4, if you open the bracket, minus y power 5 dy. Now we need to integrate this, sub in the limits. Okay, we are at this step, so I'm gonna integrate it first. 6 over 25 y to the power 4 over 4 minus y cube over 3. That's the first integral, plus 3 over 50 4y power 5 by 5 minus y power 6 by 6. That's the second integral, 2 to 4. Now we have to carefully simplify this, so I'm going to use my calculator straight away. When you sub in upper limit, 2 power 4 over 4 minus 2 cube over 3. That's 4 over 3 minus. When I sub in lower limit, it's 1 over 4 minus 1 over 3. That's minus 1 over, so plus 1 over 12 times 6 over 25 plus. Here, apply the upper limit first. 4 times 4 power 5. Both are like 4 power 6 actually. 4 power 6 divided by 5 minus 4 power 6 divided by 6. 4 to the power 6 divided by 6. 2048 over 15 minus the lower limit now. 4 times 2 to the power 5 over 5 minus 2 to the power 6 over 6. 224 over 15. Let's calculate this now. So 6 over 25 times 4 over 3 plus 1 over 12 plus 3 over 50 times 2048 minus 224 divided by 15. 1909 over 250. 1909 over 250 is the value of E of x square. Leave it as it is, do not change it to decimal. Now the next part, E of y is also given, find variance of y. The formula is variance of y is E of y square minus E of y whole square. So the answer we just got, 1909 over 250 minus E of y is given here, whole square. Let's get the value. The answer minus 2.696 square. 0.3675 dot when you round it to 3 significant figure, 368. Part E now. Find the value of y for which P of y is this. Okay, if the probability, okay, the function is defined from 1 to 2 to 4, right? So we have a graph here and then another graph here, right? The total area, if you calculate the total area below the curve, it should be equal to 1, right? Okay, if you take the point y, we don't know where the y is, but we know the area on the right hand side of y is, let's say y is here, we don't know where it is, okay, but the right hand side is 0.9. So definitely the left hand side area will be 1 minus 0.9, right? Okay. Now, the next thing we should know where the y is, whether here between 1 to 2 or 2 to 4. That's when we go back to the function. When you replace 2 here, we got f of 2 is 6 over 25, right? The value of 6 over 25 is 0.2. So here the function value is 0.2, but we are talking about the function value 0.1, right? So that tells us definitely the y is between 1 to 2. We don't know where exactly, but it should be between 1 to 2. So we don't need this graph. So let's say y is here. When you sub in y into the function, the value of the function is 6 over 25 y minus 1, right? That's a function. Look at the function, right? Okay. So basically we need to find the area of this triangle and equate it to 0.1, because the 0.1, the probability till y, that means this area is 0.1. So you can write half base is, this length is y minus 1 times this height is the y coordinate of the point, the function 6 over 25 times y minus 1 is 0.1. Y minus 1 times y minus 1 whole square. Half times 6 over 25, bring it to the other side. Let's calculate half times 6 over 25 first. We get this value 3 over 25. Okay, goes to the other side, becomes 25 over 3. 25 over 3 times 0.1. You get 5 over 6. So y minus 1 will be plus or minus square root of 5 over 6. Okay. Square root of 5 over 6 is smaller than 1 actually, right? So y can be 1 plus this or 1 minus this, but definitely it cannot be 1 minus this. That becomes smaller than 1. That means y should be somewhere here, right? So it should be 1 plus this. So you don't need to write any explanation here. You can straight away write, therefore y is equal to, they want the value of y to 3 significant figure. First write it this way. So 1 plus square root of 5 over 6. 1.91 is the answer. 1.91, that's all.